Good morning, everyone, and welcome back to the Mooc dedicated to the geothermal energy value chain, organized by Saipem and the University of Urbino. This is our sixth lesson, and we've been exploring the value chain. Today's lesson focuses on the minerals that can be extracted from the geothermal brines.
E la lezione di oggi è dedicata ai minerali che si possono estrarre dalle brine geotermiche. A
This
tenere
lesson
questa
will be taught
lezione
by Andrea
saranno
Dini,
Andrea
Director of
Dini,
the
direttore
Institute of
dell'Istituto di
Geosciences and Earth
Geoscienze e
Resources at the
Georisorse
CNR
del
National
CNR,
Research
e Mauro
Council, and
Fehervari,
Mauro
che invece
Fehervari,
è di
a Process and
Saipem
Systems
ed è
Innovator at
un
Saipem.
innovatore di processo e di sistema in Saipem per l'appunto.
This
Questa
is
è
the agenda for today's
l'organizzazione
lesson.
della
The
lezione di
first
oggi. La
part will be
prima
taught
parte
by
sarà
Andrea
tenuta da
Dini,
Andrea
who you
Dini,
can
che
already
vedete
see here
già
with me,
qui
who will
insieme a
cover
me,
the geological and
e lui
geochemical
si
aspects,
occuperà
while the
di
second part will be
aspetti
taught by Mauro
geologici
Fehervari,
e
who will
geochimici,
discuss technologies
mentre
and
nella seconda
processes.
parte sarà Mauro Fervari a parlare di tecnologie e di processi. Adesso
Welcome to both
Mauro,
Andrea and
intanto vi
Mauro,
do ad
and thank you for
entrambi il
participating in
benvenuto
this
e vi
lesson.
saluto e vi ringrazio per la vostra partecipazione a questa lezione.
Buongiorno.
E Mauro,
Mauro, I'm
adesso
going to take
ti
you off the screen for
escludo
now,
un attimo
and you'll
dallo schermo
return for the
perché
second
poi
part.
ritornerai
I'd
nella
now like
seconda
to hand the floor
parte
to
e
Andrea
lascio
Dini, who,
invece
as I
la
mentioned, is a
parola ad
senior
Andrea che
researcher at the
presento.
National
Allora,
Research
Andrea
Council,
Dini, l'ho già
CNR,
detto, è
where
un
he directs
senior
the Institute of
researcher
Geosciences and Earth
presso il
Resources.
Consiglio Nazionale delle Ricerche, CNR, ed è direttore dell'Istituto di Geoscienze e Georisorse ed è lui
Andrea
che
will
ci
talk to
parlerà
us
degli
about the geological
aspetti
and geochemical
geologici e
aspects of mineral
geochimici
extraction
dell'estrazione di
from
minerali
geothermal
dalle brine
brines.
geotermiche.
Andrea, over
Andrea,
to
a te
you.
la parola.
Thank
Grazie,
you. Good morning
buongiorno,
and welcome,
benvenuti
everyone.
a tutte e a tutti.
I'm quickly going to start with the first
Vado
slide by
rapidamente a
introducing a
passare
historical
alla prima
aspect of
slide
what is somewhat the
per
topic of
iniziare
minerals and metals
dall'aspetto
from geothermal
storico
resources.
di quello che è un po' il tema minerali, metalli dalle risorse geotermiche.
You
Conoscete
all know
tutti
about
l'Arderello,
l'Ardarello, a geothermal system in operation and extraction since the beginning of the
fin
19th
dall'inizio del
century.
Novecento.
It was
È stato
perhaps
forse
practically the
praticamente il
first
primo
example
esempio di
of the industrialization of
dell'energia
geothermal energy.
geotermica
And
e
even
ancor
before that,
prima,
about
un
a
secolo
century
prima
before
che venisse
electricity was
prodotta energia
produced,
elettrica, è
it
stato
also
anche
served
il
as the precursor
precursore
to the
dell'estrazione di
extraction of
metalli dai
metals
fluidi
from geothermal
geotermici. Appunto,
fluids.
all'Arderello nel
In
1818
1818,
è
mining
iniziata
operations
un'attività
began in
estrattiva
Lardarello for the
per la
production of
produzione di
boric acid.
acido borico che era
Boric
presente in
acid was
piccole
present
quantità
in
all'interno
small
dei fluidi
quantities in
geotermici,
geothermal fluids,
soprattutto
especially in
nei vapori
geothermal
geotermici
vapors,
che poi
which
andavano
then
a
intercepted
intercettare
small,
piccoli
shallow
acquiferi
aquifers near the
superficiali
surface,
vicino alla
gradually
superficie e li
enriching them with
arricchivano
boric acid and
progressivamente
other
di
substances.
acido borico e altre sostanze e si
Boron salts,
formavano
especially the
naturalmente dei
boron
sali
mineral
di
sasolite,
boro,
which is a
sali di boro,
solid boric
sassoliti
acid,
soprattutto,
were
che è
naturally
l'acido
formed.
borico solido.
From that
E da
experience, in
quell'esperienza
short,
poi è
an
nata
industry was
un'industria che
born,
poi
which
all'inizio
then,
del
at the
Novecento si è
beginning of the
trasformata
19th
nell'industria di
century,
produzione
transformed
di
into the
energia
geothermal
termoelettrica.
energy production
Quindi siamo
industry. So,
assolutamente dei
in
precursori in
Italy, we
Italia
are
anche su questi
absolutely
aspetti, non solo
pioneers in
sull'aspetto
these
energetico.
aspects as well, not just in the energy
Andando
aspect.
avanti, guardiamo
Moving
un po' così,
forward,
ecco.
let's look at it a bit like this.
Questi
These
metalli,
metals,
sapete
as you
benissimo,
know very
l'interesse è
well,
cresciuto
have seen
moltissimo
interest growing
negli
enormously
ultimi
in recent
anni
years,
a causa
precisely
appunto di
because of
quella che è
market demand for
la
metals,
richiesta sul
also defined
mercato
as
di
critical or
metalli, definiti
strategic,
anche
that will
critici,
be needed for the
strategici,
implementation of the
perché
energy
serviranno per
transition.
la realizzazione, per la messa a terra della transizione energetica. E, tra
Among
questi
these metals
metalli
present in geothermal fluids,
presenti
there
nei
are
fluidi
also some
geotermici
very
ci sono
banal
anche
chemical elements.
degli elementi chimici anche
For
molto
example,
banali, se
silica,
vogliamo.
more
Ad esempio,
specifically
la silice,
silicon,
il
is a chemical
silicio.
element found
Ecco,
in many
il
geothermal fluids
silice
around the world.
è
There
un
are
elemento
already
chimico
small
presente in
plants
molti fluidi
producing colloidal
geotermici
silica,
in
such
varie
as the
parti
one
del
shown on this
mondo
slide,
e
which is located
esistono
in
già
New
dei piccoli
Zealand.
impianti che producono silice colloidale, come ad esempio quello che vediamo qui nella slide, che è in Nuova Zelanda, appunto. Questo è
This
un
is an
esempio
example of
di
an
attività già in
activity
corso,
already
cioè
in
qualcosa di
progress,
reale, non è
something
qualcosa
tangible
su cui
and
dobbiamo
real.
fare
It doesn't
ricerca
require
scientifica,
further
ricerca
scientific
industriale,
or
per
industrial
cui ecco, questa è
research
una
to confirm
realtà
its
che
feasibility.
possiamo
It's a
già
reality
andare a
we can
vedere e
examine
anche a
and study in
studiare in
detail.
dettaglio.
However, perhaps the most interesting aspect is understanding how the extraction of chemical substances from geothermal fluids intersects with the management challenges of a geothermal field. In other words, if the fluid contains salts, these salts can precipitate when the fluid rises to the surface and enters the plant due to changes in pressure and temperature, potentially causing operational problems.
Possono andare incontro alla precipitazione di questi sali e quindi alla creazione di problemi.
I won't go into these issues in detail, as you are already familiar with them. However, there are various forms of scaling and precipitation along pipelines. What was once regarded purely as a problem is now being seen as an opportunity to extract valuable materials that can support the energy transition. This diagram may look a bit complicated, but don't worry. It's simply a summary of the chemical elements present in geothermal fluids. If you look at the legend, you'll see geothermal fluids from almost every part of the world. The first point to keep in mind is the remarkable variability, the wide range in concentrations of each chemical element and compound across different geothermal fluids worldwide. This information highlights a fundamental challenge. The extraction of these elements from geothermal fluids cannot be approached in a standardized way that works universally around the world.
Non può essere affrontata in un modo standardizzato, che è valido ovunque nel pianeta.
In other words, each geothermal field and each geothermal context has its own unique fluid chemistry and specific concentrations of elements. These elements can also vary over time depending on how the geothermal field is operated. As a result, the methods developed to extract boron, lithium, or colloidal silica must be tailored to each field, which requires substantial scientific and industrial research. This is necessary. There is no ready-made kit for extracting lithium from geothermal fluids that you can simply buy off the shelf. Therefore, any company aiming to address this challenge must act decisively, developing a comprehensive process that includes both fundamental and industrial research. You see, in addition to chemical elements of interest, such as boron and potassium, geothermal fluids also contain many gases, including a large number of non-condensable gases. In many cases, these gases provide information about the magmatic system that generates and sustains the heat driving the geothermal system. Vice versa. Most of the water in geothermal fluids is typically of meteoric origin, with smaller contributions sometimes coming from marine water, magmatic water, or formational water. However, around the world, most geothermal systems are fueled primarily by meteoric water. Here, in even more detail, when we examine the concentrations of certain metals, whether precious or base metals like copper, lead, or zinc, we again see significant variability in their level of concentration in the geothermal fluids. From the scale, measured here in parts per billion, or ppb, we can deduce that these geothermal fluids are generally not ideal for extracting metals of this type. On the other hand, these fluids are very promising for elements like lithium and boron, which is actually a metalloid rather than a true metal, as well as for other valuable chemical elements. But we certainly wouldn't open a production facility for gold or silver in a geothermal system, even though some companies have considered it in the past. Here
Ecco,
again
ancora qua
is a
una
roundup of
tabellata di
geochemical
analisi
analyses of
biochimiche
geothermal
dei
fluids.
fluidi geotermici.
You'll notice that lithium,
Vedete
boron, as
appunto
well as
sono
potassium,
evidenziati
rubidium,
litio,
and silica
boro,
are
ma anche
particularly
potassio, anche
highlighted.
rubidio e
These are
anche
the
appunto la
most
silice. Appunto,
characteristic
questi sono gli
elements with
elementi
the greatest extraction potential
più
from geothermal
caratteristici
fluids,
e con
including
maggiore
those found in
potenziale di
Italy.
estrazione dai fluidi geotermici, anche dai fluidi geotermici presenti in Italia.
Some are
E alcuni sono
clearly
chiaramente
metallic elements,
elementi
such
metalli
as
critici,
lithium and
chiaramente
boron.
come il litio e il boro.
Others, like silica,
Altri,
can be
diciamo, come
considered
la
critical,
silice,
but they are clearly
possono essere
elements with
considerati
less
critici, ma
impact, even
chiaramente
in the media,
sono
right?
elementi con
We
minore
hear about
impatto,
lithium, but we
diciamo, anche
rarely hear about
mediatico, no? Si
silica.
sente parlare di litio, raramente si sente parlare di silice. Per cui
So,
ecco, questi
here is a
sono
roundup
una
of analyses
carrellata
from
delle nuove
around the world,
analisi da
from
tutto il mondo,
Salton
da
number
Salton
1
Sea
up to
numero
Monte
1 fino a,
Amiata,
credo ci sia anche il
which
Monte
I think is
Amiata da fare
analysis number 20.
l'analisi numero 20.
You can
E
already
già qui
see great
vedete
variability
per il
here for
litio
lithium.
delle grandi
Concentrations
variabilità, si
range
va
from less
da
than 1
valori
milligram per
inferiori al
liter to
milligrammo
very
litro
high,
fino a
noteworthy levels,
valori invece a
even
concentrazioni
exceeding
molto
300
interessanti,
milligrams per
addirittura
liter.
superiori ai 300
These
milligrammi
data
per
make
litro.
the prospect of
Questi sono
extracting lithium
dati
from
quindi
geothermal
che
fluids
rendono
highly
molto
encouraging.
incoraggianti il pensare ad uno sfruttamento di litio da questi fluidi geotermici. E in
In fact,
effetti
there are very
esistono delle
advanced
realtà molto
exploration and
avanzate di
industrialization projects.
esplorazione e di industrializzazione. Qui
Here
vedete una
you see a
foto del
photo of the
progetto Future
Hell's
Cell
Kitchen in
del
Salton Sea,
Hell's Kitchen,
California,
scusate,
in Southern
di
California.
Salton Sea in
This is a
California, al sud della
well-known geothermal
California. È
system,
un sistema
productive since
geotermico molto
1982,
conosciuto,
and
produttivo fino
currently a
dal
project is
82,
underway to extract
e in
lithium
questa
from its
fase, in questo
fluids.
momento, stanno sviluppando un progetto per estrarre appunto litio da questi fluidi geotermici.
The estimated
Le
reserves are
riserve
substantial,
stimate
around
sono importanti, si
800,000
parla di
tons.
800.000
The
tonnellate
plan is to produce
e
approximately
l'idea è
10,000
quella
tons of lithium
di
carbonate per
produrre
year,
circa
which corresponds to
10.000
roughly
tonnellate di litio
20% or
carbinato
about
l'anno,
2,000
non è
tons
litio
of
metallo.
lithium metal
Quindi
annually.
10.000 tonnellate sarebbe più o meno il 20%, siamo sui 2.000 tonnellate di litio metallo all'anno.
This
Questa è una
project is
realtà che
expected
entrerà
to
in
enter production
produzione
relatively
in tempi
quickly,
abbastanza
if
rapidi,
everything
se
goes
tutto va
according to plan,
come sembra,
by
quindi nel 2027.
2027. This
Questa
project
realtà
is
è forse la
perhaps the
più
most
avanzata,
advanced.
ci sono altri
There are
progetti
other
abbastanza
fairly advanced
avanzati nell'alta
projects in
valle
the
del
Upper
Reno,
Rhine
tra
Valley
Germania e
between
Francia,
Germany and France,
e
and even in
diciamo anche
Italy.
in Italia, come
As we'll
vedremo,
see,
si sta
these initiatives
pensando
are exploring the
a questo tipo
combination of
di
electricity
attività, cioè
generation
unire la
and
produzione
possibly
di energia
district heating
elettrica e
with the
magari anche
production
quella di
of lithium,
riscaldamento alla
boron, and
produzione
other
di
metals or
litio,
chemical
boro e
compounds
altri
valuable to
metalli
the industry.
o composti chimici interessanti per l'industria. Qui
Here you
vedete
see some
appunto
geological information on the
qualche
Salton Sea
informazione
system.
geologica
The
sul
Salton Sea
sistema di
geothermal
Salton Sea.
system is
Salton
located
Sea
just
è
northwest of the Gulf of
localizzato
California.
appunto subito a nord-ovest del Golfo della California.
It
È
is
una
the continuation
prosecuzione
of a zone of transfer
di
faults
di
and
fagli
strike-slip
trasformi,
faults that
di
connect
transfer
with
fault,
the San
scusate,
Andreas
e
fault system.
di faglie trascorrenti che poi vanno a collegarsi anche col sistema della Sant'Andreas Fault. E
Along
lungo
this
questa zona
strike-slip zone,
trascorrente che vedete
which
a
exhibits right
circa a
lateral,
destra, si
dextral
sviluppano dei
kinematics,
bacini di
pull-apart
pull-apart,
basins
delle zone in
develop. These
estensione,
are
dove
extension
avviene
zones
sia la
where sedimentation
sedimentazione, ma
occurs,
anche,
but
la cosa
more
più
importantly,
importante, in
they
questi bacini
also
di
serve
pull-apart
as
avviene
pathways
la
for
risalita del
magma ascent
magma
from the
dal
mantle
mantello e
and
dalla
lower
crostata
crust.
inferiore.
As a
E quindi è
result,
una zona,
these
questi
pull-apart
bacini di
basins
pull-apart
become
sono
zones
zone
that
che
focus
focalizzano
magmatic
i
processes,
processi
allowing them
magmatici,
to
lo
interact
fanno
and
innestare
interlock
l'uno dentro
over a
l'altro
temporal
durante
evolution that can
un'evoluzione
last
temporale che
several
può
million
durare anche
years.
alcuni milioni di anni. Nel caso di
In the
Salton
case
Sea
of the
sono
Salton
almeno
Sea
5 milioni di
geothermal
anni
system,
che il
the
sistema
magmatic
magmatico è
system
attivo,
has been active
e
for at
questo
least 5
chiaramente
million
crea
years.
un'anomalia termica
This
molto
long-lived
concentrata,
activity
molto
has
ben
produced a highly
focalizzata, che
concentrated
sostiene a
and
lungo termine
well-focused thermal
processi di
anomaly
circolazione
that
idrotermale
sustains
di acqua
persistent
meteorica
hydrothermal
fondamentalmente,
circulation. The circulating fluids, primarily meteoric water, efficiently leach the surrounding rocks, leading to the formation of reservoirs enriched in specific metals. In the case of the Salton Sea geothermal system, the presence of large volumes of ignimbrite and highly evolved rhyolitic domes, rocks that are rich in lithium, allows lithium to become concentrated in the liquid phase, specifically within the geothermal fluids themselves. This is therefore a highly unique geological setting in which sedimentary, magmatic, and hydrothermal processes are confined within a relatively small volume. It is within this limited space that the lithium-rich geothermal system of the Salton Sea geothermal system develops. However, the use of the various chemical elements present in the geothermal fluids should not be viewed as something limited only to traditional geothermal systems. One can also target brines, deep-seated saline fluids that are not directly linked to magmatic systems, but are instead associated with basinal environments, such as sedimentary basins or even oil and gas systems. Indeed, all the formational saltwaters linked to oil and gas systems generally contain a significant concentration of lithium, ranging from a few parts per million to, in some cases, more than 100 parts per million. Some companies, such as New Zealand's Geo40, have developed systems for extracting lithium from these types of fluids, and they have even developed a mobile system. You can see a trailer effectively carrying a mobile separation plant that is currently being tested in the region between the United States and Canada. The Alberta region hosts fluid systems characterized by deep saline aquifers that are closely associated with oil and gas reservoirs. This example shows a geological cross-section of the Leduc Reservoir area in Alberta, Canada. Here, a very significant resource has been identified, with lithium concentrations reaching up to 75 milligrams per liter. This resource could support substantial industrial activity, with an estimated production potential of around 12,000 tons per year of lithium carbonate, although the actual potential may be considerably higher. See, 36,000 tons per year for 50 years, so it's a significant deposit. Clearly, producing between 1,000 and 2,000 tons of lithium metal per year represents a very significant industrial activity. However, it remains orders of magnitude smaller than lithium production from pegmatite deposits in Australia, where annual output can reach around 100,000 tons of lithium. However, these production activities contribute not only to local value chains, for example in Canada for lithium batteries, but also help diversify production regions, thereby enhancing geopolitical security in the countries where this activity takes place. Among other possibilities, additional chemical elements are being studied to determine whether they can be extracted from geothermal fluids, for example, the well-known rare earth elements. These elements, ranging from lanthanum to lutetium, have indeed been analyzed, but their concentrations in geothermal fluids are extremely low. You see, here we go from parts per trillion to parts per million, but we usually don't even get to 1 parts per million. So it's clear that the idea of extracting rare earth elements from geothermal fluids is highly futuristic, essentially a challenge for the future. It is possible that the development of new materials, advanced membrane systems, or improved ion exchange resins could make this feasible in the future. For now, it's something that can't be applied industrially. After this brief overview, to give you some insight into the extraction potential of certain metals and minerals from geothermal fluids, I'd like to focus in a bit more detail on the Italian geothermal system. Italy, as you know, has relatively young geology, and even its oldest rocks do not date back earlier than the Paleozoic era. Consequently, Italy does not possess the same mining potential as countries like Canada, Australia, the United States, or Brazil. However, despite the absence of significant pegmatites containing spodumene, although a few very small ones exist in the Eastern Alps, Italy does have other types of minerals and potential concentrations of economically interesting deposits. First of all, Italy has very promising geothermal fluids in the interior of the Apennines, in the Tyrrhenian Basin and the Peri-Tyrrhenian zone, in short, throughout the volcanic region stretching from Tuscany to Sicily. Additionally, there are highly interesting saline fluids located in the trench zone, the Apennine foredeep, and the tectonic front of the Apennines. In these areas, there are some hot springs you all know about: Salsomaggiore, Castrocaro, Tolentino, where fairly significant concentrations of lithium have been measured. We also find some geologically anomalous rocks, such as the paraluminous granitic formations in Tuscany, the most recent of which date from the Miocene to the Plio-Pleistocene, approximately 8.5 to 1.5 million years ago. These granites contain significant lithium concentrations within minerals such as tourmaline and some rare lithium-rich micas. There are also Permo-Jurassic volcanic sedimentary sequences that cover the entire Alpine arc, extending from Liguria and Piedmont to Lombardy and Alto Adige. Here, there is considerable potential for identifying volcanic sedimentary layers highly enriched in lithium. We're talking about concentrations in the range of thousands of milligrams per kilogram, or micrograms per gram if you prefer. However, the greatest potential for lithium in Italy is undoubtedly linked to geothermal fluids. This is not only due to the concentrations involved, but above all because the type of extraction is more sustainable and socially acceptable. As we'll see in more detail, Tuscany and the Lazio Campania region host very different magmatic rocks, yet many of these exhibit remarkably high lithium concentrations. In this diagram, the y-axis shows lithium concentrations in micrograms per gram or milligrams per kilogram, as you prefer, while the x-axis represents silica concentrations. You can observe that two distinct extremes emerge. On the right, with the high silica values, are the magmatic rock fields of Tuscany. These paraluminous granites contain lithium enrichments of up to 2,000 to 3,000 milligrams per kilogram. These very high values, which until a few years ago were not considered economically viable, are now recognized as unconventional lithium deposits. For example, in Cornwall, a mine is about to open that will exploit rocks just like these. On the left, you can see the blue field representing the Lazio Campania magmatic province, where volcanic rocks exhibit lithium concentrations of up to 100 to 150 milligrams per kilogram. These are not mining-grade values per se, but they are very interesting because the lithium is contained within the volcanic glass, making it readily mobilized by geothermal and hydrothermal fluids. This is the example of Tuscany. These are the distinctive zinwaldite and siderophyllite, bearing tourmaline granites, which exhibit very high lithium concentrations and could therefore be considered a hard rock lithium resource. However, as you can see in this photo, the location of these rocks is particularly beautiful. It is located in the heart of the Tuscan Archipelago National Park, making it a splendid natural laboratory for scientists, but not an area suitable for mining at this time. However, these rocks provide valuable insights, as recent research has shown, allowing us to identify and explore similar deposits in other parts of the world. As I mentioned earlier, geothermal fluids are the most promising for lithium production in Italy, but the saline fluids of the Alpine foreland also merit further study. In recent years, we at the CNR, together with the University of Pisa and other Italian universities, have been conducting studies to understand the potential and mechanisms of lithium enrichment, both in the cold foreland areas and in the hot Tyrrhenian back arc region. Here you can see the variability of lithium concentrations within both the geothermal fluids and the low enthalpy fluids of the foreland area. The high enthalpy geothermal fluids are the red symbols. The colder ones from the foreland are the blue symbols. And you can see something very interesting you should remember. You see, it's not just the lithium concentration that matters. The magnesium to lithium ratio is also critically important. So here you understand the geothermal fluids of the Tyrrhenian back arc area are much more interesting than those of the foredeep area because they have a very low, sometimes extremely low, magnesium-lithium ratio. This will greatly aid, as you will see in the second part of the lesson, in lithium extraction during direct industrial processes. So, let's focus for a moment on the geothermal area. There are two main magmatic provinces, the Tuscan province, which hosts lithium-rich granites, and the Roman Campanian province, characterized primarily by volcanic rocks and extensive ignimbrite deposits, which also show anomalous lithium concentrations of up to 100 to 150 milligrams per kilogram. This distinction between the two Roman provinces leads to differences in their geothermal systems and fluid chemistry, and consequently affects the presence, distribution, and speciation of lithium and other elements within these geothermal fluids. Looking in more detail, we see that geothermal fluids associated with the Tuscan systems, those in contact with granites, including the Paleozoic metamorphic basement rocks of Tuscany, have greater difficulty leaching lithium from the surrounding rocks. This is because lithium in these Tuscan rocks is primarily hosted in very resistant minerals, such as tourmaline and certain types of mica, which require very high temperatures to release the lithium. Conversely, a geothermal system developing in contact with glass-rich volcanic rocks that have high lithium concentrations is much more effective at leaching lithium from the glassy phase, which, as we know, readily releases both lithium and boron into the fluid phase. This difference between the two magmatic provinces and the geothermal systems associated with them is particularly significant. Now, in the last few minutes of my presentation, let's look at this in a bit more detail. Here you can see an ideal section of the Larderello geothermal system. I won't go into detail here, but the geothermal system at Larderello lies at depths between roughly 3,000 and 6,000 meters. Beneath it, a magmatic intrusion is currently crystallizing, as demonstrated by the most recent projects carried out with Enel over the past decade. The thermal reservoirs are the conventional ones shown in yellow in the section, and they are hosted within the Paleozoic metamorphic basement. This basement consists of phylites, quartzite sequences, numerous biotite mica schists containing tourmaline, and several older granitic bodies associated with the Larderello system, dated between about 4 and 1.5 million years ago. All of these rocks contain lithium and boron, but these elements are not easily mobilized into the geothermal fluids. Therefore, the Larderello system is truly exceptional from the standpoint of energy production. arguably one of the most remarkable geothermal systems on the planet. It is highly productive from an energy standpoint, but it does not exhibit strong exchange with the surrounding rocks in terms of lithium and boron mobilization. Furthermore, the Lardarello system is entirely steam-dominated, which represents a disadvantage in this context. It's much better to have a liquid water-dominant geothermal system because lithium dissolves and is mobilized much more efficiently if the water is in the liquid phase than in the vapor phase. If we move slightly farther south toward Monte Amiata, we encounter a different geological section. Monte Amiata is a bit of a trade union, a transition zone between the Tuscan and Campanian magmatic provinces. As a result, the magmas feeding the Monte Amiata volcano are hybrid in nature, intermediate between the two provinces, as has been demonstrated by recent studies carried out by research groups in Florence and at the University of Florence. It is therefore clear that this system exhibits characteristics that bridge both magmatic provinces. First of all, it is a liquid water-dominated system rather than a vapor-dominated one, which gives it a greater capacity for chemical exchange with the surrounding rocks. In addition, these rocks are potentially richer in lithium and host lithium in more easily exchangeable forms. As a consequence, geothermal fluids at Monte Amiata can contain lithium concentrations of up to several tens of milligrams per liter. Significantly higher than those typically observed at Lardarello, where concentrations are usually only a few milligrams per liter. Moving even further south, we arrive in the heart of the Roman magmatic province in Lazio, in the area of Lake Bracciano, specifically the Cesano area. The well-known Cesano geothermal system. This system never entered full production, having reached only the pilot stage before being shut down. Today, however, it is perhaps the area with the greatest development potential in Italy for lithium, boron, and other chemical compounds hosted in geothermal fluids. The system is characterized by thick ignimbrite sequences and potassium-rich volcanic rocks of the Roman province, which contain abundant volcanic glass enriched in lithium and boron, elements that are readily exchangeable with liquid water. The Cesano system is liquid water dominated, and for this reason represents the geothermal system with the highest potential in Italy. Indeed, fluids analyzed in the 1970s and 1980s revealed lithium concentrations reaching up to 300 to 400 milligrams per liter, which are truly exceptional values. This represents an ideal scenario. At present, many mining companies are interested in developing industrial activities here. It's a particularly exciting opportunity because this area could simultaneously produce electricity, provide district heating, extract critical elements like lithium and boron, and recover other chemical compounds, such as potassium sulfate, which is present in enormous quantities at Cesano. But why is potassium sulfate so abundant? Because in addition to interacting with volcanic rocks, the geothermal fluids likely interact with underlying Mesozoic evaporite sequences, particularly the Triassic layers beneath the alpine carbonate sequences. These include thick and hydrate deposits, which enrich the fluids with potassium sulfate and other alkali metals. The vision is to combine scientific research, industrial innovation, and sustainable industrial activity that is socially acceptable. This could involve generating electricity, supplying district heating to nearby villages, and producing lithium within a fully integrated production chain, from batteries to electric vehicles. Such an approach could generate widespread public support while creating significant societal and economic value.
E crea anche un valore pubblico appunto molto rilevante.
This type of activity is only beginning in Italy. In comparison, systems like those at the Salton Sea or in the Upper Rhine Valley are already much more advanced. Nevertheless, we hope that Italy will quickly develop its potential as well. I'll conclude with this slide. It shows a panorama from Monte Rotondo Marittimo in the Larderello geothermal field, extending to the islands of Elba and Corsica on the horizon, encompassing the entire Tuscan magmatic province and its geothermal systems. This view illustrates that these activities are not only valuable for the scientific study and natural beauty of the systems themselves, but also crucial for creating diversity in the production of critical metals, a key consideration for European and global policies in support of a sustainable future. With that, I'll pass the floor to my colleague. Thank you very much, Andrea. Thank you for your presentation. In the meantime, I'd like to welcome Mauro Fehervari back. Andrea, I'll see you shortly. We'll hold on to your questions for now and address them after Mauro's presentation.
Tra poco perché ti chiedo di attendere ovviamente per rispondere poi alle domande che nel frattempo ho visto scorrere e alle quali daremo seguito dopo la presentazione di Mauro.
Thank you. See you soon.
A tra poco.
Mauro, welcome. Mauro Fehervari, as we've already seen, is a process and systems innovator at Saipem SPA.
Presso Saipem SPA e la sua parte di relazione riguarda proprio le tecnologie e i processi.
Mauro, you now have the floor and control of the slides. Thank you, Alessandro, and good morning, everyone. Now, let's move on to the second topic of the day, how to extract not only energy, but also economically valuable elements from geothermal brines, before we even discuss the brine extracted from the underground.
Anche elementi che hanno un valore economico, prima di introdurre appunto la brine, ovvero la salamoia che viene estratta nel sottosuolo.
First, as we've already seen, we need to identify which useful elements are worth extracting, a point that Andrea Dini has analyzed thoroughly. Then we need to consider how to design processes that optimally combine the exploitation of the energy component with the extraction of minerals from the geothermal resource. Finally, and perhaps this should actually come first, we must have the appropriate technologies in place to make such operations feasible.
Dobbiamo avere in mano delle tecnologie che siano capaci di permettere questa operazione.
On this slide, I'll briefly summarize the potential of elements found in geothermal brines. I won't repeat everything we've already discussed, but it's worth noting that several elements have already been exploited historically, starting with boron. Today, the elements highlighted in red, such as silicon and lithium, are already being extracted.
Sfruttate a partire dal boro e oggi invece, riquadrati in rosso, abbiamo invece già delle estrazioni di silicio e di litio.
This does not mean that the elements highlighted in green are not of interest. Rather, they represent potential target materials for future extraction. These are the main products of geothermal brines. Along with the elements highlighted in yellow, we have also identified a series of additional elements that could potentially be recovered as secondary products or byproducts. What is crucial to emphasize from the outset is that any meaningful discussion must begin with as precise a characterization as possible of the elemental composition of the geothermal brines of interest. This step represents the starting point for all subsequent considerations, whether economic, technological, or process-related. Now, let's turn to this slide, which introduces the possible conceptual approaches for hybrid systems that combine geothermal energy production with mineral extraction.
Accoppiare l'estrazione di minerali e l'energia geotermica. In questa slide
First, we consider a high-temperature geothermal resource, essentially a high-enthalpy system. In this case, the primary objective is clearly energy production, typically electricity. However, if the associated brines are particularly rich in valuable elements, the liquid phase can be separated and further processed before being re-injected into the subsurface.
Processarlo ulteriormente prima di reimetterla nel sottosuolo.
This processing does not necessarily occur in a single step. Rather, it may involve a full-fledged production process comprising various sub-processes, including pre-treatment, mineral extraction, refinement and concentration, and in some cases, even conversion into a finished product. In this configuration, mineral recovery is treated as a byproduct of the primary goal, which remains electricity generation. A similar approach can be applied to existing geothermal systems. For example, medium enthalpy resources currently exploited for direct heat use or electricity production. In such cases, mineral extraction could be integrated downstream of a heat exchanger, such as in a binary cycle system.
A valle di quello che è lo scambiatore di calore del ciclo binario, diciamo, per la produzione di energia.
In the cases I've just described, we're essentially talking about retrofit systems. That said, this is something of a simplification because, as you can see, mineral extraction is not necessarily as straightforward as operating a geothermal plant solely for energy production. This second type of system, however, is specifically focused on extracting a target mineral, possibly along with other minerals recovered as byproducts, while the geothermal fluid itself may not have sufficient enthalpy to support energy production for external uses. Nevertheless, the energy requirements of the extraction plant could be met entirely, or at least in part, by geothermal energy. But in this case, it is even more evident that the entire plant must be designed and integrated in an extremely tight and coordinated manner. This is because the energy component is entirely at the service of mineral extraction, and this therefore requires a unified and highly optimized design.
Commistione necessiterà di un design unitario e estremamente ottimizzato.
I should also point out that the schemes I've presented are not fixed or standardized configurations, as was mentioned earlier. Each geothermal field is different, with its own peculiarities, challenges, constraints, and economic conditions. As a result, these systems, which are inherently hybrid, already involve a certain degree of variability and complexity. Nevertheless, the final outcome must still be economically viable and at the same time acceptable and sustainable over the long term, including from a social and environmental perspective. Therefore, for each geothermal site where mineral extraction is also being considered, it is necessary to begin with a preliminary technical feasibility study. This study should aim to identify an optimal balance between risks, costs, and impacts in relation to the expected benefits. Now, let's focus briefly on lithium. It has already been explained why lithium is so important. It is one of the key materials in the energy transition. So let's take a look at the technological options available for its extraction. In this slide and the following ones, I'd like to give a brief overview of the technologies that are currently available or under development for the direct extraction of lithium from brines of various origins, not necessarily geothermal. These include marine brines, salt lakes, formation waters from oil and gas wells, as we discussed earlier, as well as brines obtained from the dissolution of salts in salt flats. All the technologies shown here, which I'll describe in a bit more detail, fall under the category known as DLE, or direct lithium extraction. These technologies can be grouped into several classes based on their underlying physicochemical principles.
Contengono un po' il principio fisico-chimico per cui sono accomunabili, ecco.
They include absorption technologies, ion exchange technologies, solvent extraction technologies, membrane or electrochemical technologies, and, more recently, approaches based on biological or biotechnological systems, although, as we'll see, these are currently the least mature in terms of technological readiness.
Anche se, come vedremo, queste sono le più acerbe dal punto di vista di maturazione tecnologica.
Now, a few words on how the operating principles of these technologies work. In these three diagrams, we illustrate the mechanisms of lithium adsorption, ion exchange, and solvent extraction.
L'assorbimento, lo scambio ionico e l'estrazione con solvente del litio. Stiamo parlando sempre di litio.
We are still, of course, talking about lithium. In this case, lithium is represented by the orange circles. The other circles represent the other cations present in the brine. In green, chloride is shown, representing one of the main ions in geothermal brines. And we should also note the small hydrogen ions shown in violet. As you can see on the left, we have adsorption systems. In this case, there is a solid matrix capable of adsorbing, and therefore incorporating within its structure both the lithium cation and the corresponding anion, in this case chloride. A similar situation occurs in ion exchange systems, although here we are again dealing with a solid phase. In this case, however, there is a true cation exchange process. Lithium enters the solid phase, while hydron ions, or H+, are released. In the diagram on the right, the same principles can be applied when the brine is brought into contact with a solvent, specifically a liquid solvent, that is immiscible with the saline phase. Here as well, absorption or ion exchange phenomena occur.
E anche qui si possono avere i fenomeni di absorbimento in questo caso o di scambio ionico.
In all these technologies, there is therefore an adsorption phase followed by a necessary desorption phase. Once the active sites reach saturation, the solid or liquid matrices must be desorbed in order to carry out a new adsorption cycle.
A saturazione e c'è necessità di desorbire le matrici solide o liquide per poter fare un nuovo ciclo di assorbimento.
As a result, these processes are generally discontinuous. The next three figures instead represent membrane or electromembrane systems and electrochemical systems. Here again, lithium is shown in orange. In this case, for membrane systems, the membranes, typically made of suitable polymeric materials, allow the system to be subjected to a driving force that pushes lithium to the other side of the membrane, enabling a form of selective permeation. In the membrane systems shown on the left and in the center, this driving force is provided by an electric field. The operating principle is therefore similar in both cases. The electric field causes the cations to migrate, with lithium being attracted towards the electrodes.
La forza è data da un campo elettrico che ovviamente permetterà ai cationi di essere attratti dall'elettrodo negativo.
The membranes are designed to be permeable only to ions with the appropriate size and characteristics, in this case selectively favoring lithium. In these two systems, it is possible to operate under continuous conditions, because on one side we have the brine, and on the other side the permeate, which flows continuously. In the last figure on the right, we are instead dealing with a true electrochemical system, where membranes are absent. Even in this case, however, an electric field generated by two electrodes ensures that lithium is transported and incorporated into the negative electrode. This electrode also has absorptive properties, and therefore, here too, it is necessary to regenerate the solid matrix in order to start a new operating cycle. In this case, we refer to this mechanism as intercalation.
In questo caso parliamo di intercalazione.
Now, let's take a look at the levels of technological maturity of the different direct lithium extraction technologies. In this overview, we have also included, in the last column on the right, bio-based technologies. On the vertical axis, we report the TRL, an acronym for Technology Readiness Level, which indicates the degree of technological maturity, ranging from laboratory scale testing to full commercial deployment.
Quello che è il grado di maturità tecnologica delle varie tecnologie che abbiamo citato, dalla fase di test in laboratorio fino alla fase finale di commercializzazione, dove
this scale spans from 1 to 9, with level 9 representing the highest level of technological maturity. I have also indicated a threshold at level 5, which allows us to distinguish between technologies that have already been tested successfully in the field under realistic conditions, those above level 5, and those that have so far been tested only at the laboratory scale.
Che sono quelli al di sopra di 5, rispetto invece a quelle che hanno avuto un testing solamente in condizioni di laboratorio.
As you can see, selective adsorption is currently the most advanced technology, closely followed by ion exchange. These are then followed by solvent extraction, membrane-based technologies, and electrochemical systems. Overall, this slide represents a collection of experiences developed by industrial players, universities, research centers, and startups. Finally, as mentioned earlier, bio-based technologies remain the least mature and are still at a relatively early stage of development.
Abbiamo per ultima le tecnologie bio-based che sono ancora invece abbastanza indietro.
In this slide, I want to provide a framework for the economic potential of the technologies I mentioned, looking at costs and comparing them with the market price of lithium.
Rispetto al prezzo di vendita del litio sul mercato.
As you can see in the graph at the top left, these values are based on the unit operating costs provided by the technology developers themselves, that is, the organizations that develop each of the different technologies. We see a substantial alignment across the technologies, with cost ranges overlapping quite a bit, roughly between $3.2 and $4.9 per kilogram of lithium carbonate equivalent, or LCE. This indicates that we are still in a phase where there is ample room for competition among these emerging technologies, which are still under development. There is not yet a single consolidated solution for lithium extraction, for two main reasons.
Sono tuttora in fase di sviluppo e quindi non c'è ancora una soluzione diciamo finale di quelli che sono dei processi consolidati per l'estrazione del litio.
First, each brine has its own specific characteristics and challenges. Second, we are still in a very active phase of technological development, meaning that improvements are expected in the future. New solutions may emerge that are currently off the radar, and hybrid approaches combining principles from different technologies are possible.
Di miglioramenti in futuro, ma anche di la comparsa di ulteriori soluzioni che in questo momento sono ancora magari fuori dal radar, e anche la possibilità di poter fare delle soluzioni di tipo ibrido, prendendo principi dalle diverse tecnologie che abbiamo citato.
At the bottom left of the slide, we show the OPEX and overall costs of DLE technologies applied to geothermal brines, compared with traditional extraction methods from evaporation ponds and minerals like spodumene.
Dalle brine geotermiche, in confronto anche con i sistemi, diciamo così, tradizionali di estrazione dagli evaporation ponds e dal minerale come lo spodumene.
As you can see, the costs for geothermal brines are roughly $5 to $6 per kilogram of LCE, highlighting their considerable competitiveness relative to other systems.
Per le brine geotermiche c'è sicuramente una competitività notevole rispetto agli altri sistemi.
On the right, we have a graph showing the historical trend of lithium prices from 2020 to the end of 2025. Today, or at the end of 2025, the price is around $10 per kilogram of LCE. However, there has been significant volatility, with peaks reaching $40 to $80 per kilogram of LCE in 2022 to 2023. This illustrates the high variability of lithium prices, which is a crucial factor to consider when planning an investment, given that a lithium plant is a decades-long commitment.
La volatilità di questo prezzo. Questo è importante nel momento in cui si voler in qualche maniera fare un investimento, perché appunto un investimento su un impianto di litio è qualcosa che durerà poi decenni.
Now, let's move on to other elements. As I mentioned earlier, lithium is not the only element present in geothermal brines. There are many others. Each of these has its own extraction technologies, each with different levels of technological maturity. Many of these elements are also classified as strategic and critical by both the European Union and the United States. I would like to point out, as mentioned earlier, that there is also potential for extracting rare earths, even though these technologies are still at a relatively low TRL. I mention this because we might provide a concrete example later.
Una possibilità di estrazione, anche se siamo ancora a un TRL abbastanza basso. Lo cito perché dopo magari faremo un esempio su questo.
Now I'll move on to a couple of concrete examples of lithium extraction. The first uses a proprietary process and technology known as ILiAD, which stands for Integrated Lithium Adsorption-Desorption. This is a commercial scale case and represents a nearly complete production process.
È arrivato a un livello di sfruttamento commerciale e risulta un po' completo in tutta la sua filiera, e poi ci sarà
To close, I will also present a highly innovative initiative, unfortunately still at the laboratory stage, for rare earth extraction. This slide shows the general scheme of the ILiAD process, developed by an American company. It is based on adsorption technology, using a proprietary adsorbent material, entirely patented systems.
Sono sistemi brevettati, quindi proprietari.
This system claims to achieve up to 95% lithium recovery while removing over 99% of foreign elements, even from complex brine compositions. Importantly, it was designed to be applicable to all types of brine, including those from geothermal systems, potentially as a downstream addition to an existing power plant.
Magari aggiungendo a valle di una centrale già esistente.
On the ordinate, shown on the logarithmic scale, we have lithium concentrations along the process. The Iliad process consists of 4 main stages. The first stage involves treating the brine to remove certain chemical species, typically the most abundant, that could cause issues in downstream processes. The second stage is the direct lithium extraction itself, followed by a third stage of purification and concentration, and finally a fourth stage producing the finished product, ready for use in lithium batteries.
Di produzione del prodotto finito, ovvero quello che è già direttamente utilizzabile per le batterie al lidio.
And now let's look at how the adsorbent material is made.
Allora, qui abbiamo
this adsorbent material is specifically selected for lithium and is patented.
Per il litio ed è anche questo brevettato.
It exhibits high adsorption capacity, as indicated by the values on the right, and shows much higher selectivity compared to other ions such as sodium, potassium, and magnesium. Magnesium is particularly challenging as it has similar chemical characteristics to lithium, making separation more difficult. In the center, we see the typical structure of the adsorbent compound. It is an aluminum hydroxide with a layered structure containing cavities that are similar to lithium, while chloride ions are intercalated between the layers. This intercalation is necessary to maintain the electrical neutrality of the system. Now, let's look more closely at the process. At the input, the brine composition is similar to what is extracted from the production well, meaning it contains a mixture of many chemical species.
E quindi dentro ci può essere un po' di tutto, sarà ricca di molte specie chimiche.
In this first stage, which consists of 3 specific treatment sections, the process first precipitates iron and silica as iron silicate.
Innanzitutto di precipitare ferro e silice come silicato di ferro.
By raising the pH, manganese and zinc are separated as insoluble hydroxides. Finally, the pH and temperature are adjusted to make the brine compatible with the next stage, the lithium extraction stage.
Il successivo stadio, che è quello appunto di estrazione del litio.
This lithium extraction stage is the heart of the system. Not only does it separate lithium, but it also concentrates it by approximately 10 times the initial concentration.
Anche una prima concentrazione di circa 10 volte rispetto alla concentrazione iniziale.
As you can see, this stage is divided into 4 process zones, labeled A, B, C, and D. While they appear as a linear sequence, in reality they function in a cyclic manner, alternating over time to form what is called a simulated moving bed, enabling a continuous adsorption process.
Funzionano avvicendandosi funzionalmente nel tempo a comporre un sistema detto a letto mobile simulato che permette di ottenere un processo continuo di assorbimento e desorbimento.
So how does a simulated moving bed work? As illustrated in the diagram at the bottom left, we have packed columns filled with the adsorbent material. Pre-treated and conditioned brine flows through these columns in countercurrent with an eluent, typically water, which facilitates lithium desorption.
Da questa sorta di salamoia già pretrattata e precondizionata e in controcorrente abbiamo un eluente invece che viene fatto fluire all'interno delle colonne e si tratta peraltro di acqua che permette il desorbimento. Quindi
By alternating the inputs and outputs of this system, lithium is collected as the extract, while the remaining ions are removed as what is termed as the refined stream, though this term can be somewhat misleading, since the primary focus is on lithium recovery rather than true refining. So, we have a system that must be operated by continuously switching the various inputs and outputs across the different stages in order to achieve a continuous process. This is made possible by a patented system of rotary valves.
Rotanti, che peraltro è anche questo brevettato.
In short, lithium extraction systems are anything but trivial. The third stage consists of 5 subsections and is dedicated to impurity removal prior to concentration. At this point, the fluid is no longer a brine, but rather a solution with a high lithium concentration that still contains trace amounts of other ions.
Questa che non è più una brine, ma è una soluzione ad alte concentrazioni di litio dove ci sono tracce degli altri ioni che però vanno ancora rimossi perché noi dovremo
These impurities must be removed before concentration, because otherwise they would also be concentrated along with the lithium. This stage, therefore, focuses on the removal of calcium, magnesium, and other divalent ions such as strontium and barium. Once these species have been eliminated, the process can proceed to 2 concentration steps. The first concentration step is reverse osmosis, which increases the lithium concentration from approximately 2,500 ppm to about 5,000 ppm. This is followed by a triple effect evaporation stage. As is evident, these concentration steps require a significant amount of energy. This is one of the points at which geothermal energy, if available, becomes particularly advantageous, given that the process is integrated within a geothermal system. The final stage involves the conversion of lithium chloride, which is the output of the extraction process, but is not suitable for battery production. Consequently, it must be converted into lithium carbonate or lithium hydroxide. Now, moving on to the final slide. This is dedicated to an example of rare earth mineral extraction.
È dedicata a un esempio di mineral extraction di terre rare.
Here, I present a highly innovative approach, markedly different from those discussed so far, developed by the Pacific Northwest National Laboratory. This method is based on the use of functionalized magnetic nanoparticles. How does it work? These nanoparticles are composite materials formed by combining an absorbent material with a magnetic core made of iron oxide.
Materiale assorbente con un nucleo magnetico che è costituito da ossido di ferro.
The iron oxide core is then surrounded by a shell of a support material, which can be silica or even a metal organic compound. With the acronym MOF, we refer to metal organic frameworks. These support materials must be further functionalized with chemical groups that exhibit a strong and selective affinity for trivalent cations typical of rare earth elements, such as lantanium 3+, neodymium 3+, and gadolinium 3+, which, as you know, are all trivalent. These active sites are capable of chelating the ions, meaning they bind them stably through relatively strong interactions. How does this work in practice? These nanoparticles are introduced into the geothermal brine at relatively low concentrations, on the order of about 0.05% by weight. They can be injected directly into the brine stream, essentially immediately downstream of the geothermal plant's heat exchanger. In this configuration, there is no need for complex and expensive plant infrastructure, such as adsorption beds, packed columns, or membrane systems like those discussed earlier. Once adsorption has occurred on the nanoparticles, separation is made possible by their magnetic properties. A dedicated separation stage allows the magnetic nanoparticles to be recovered efficiently. At that point, the rare earth elements can be desorbed, and the nanoparticles themselves can be recycled. Studies have shown that when designed in this way, these nanoparticles can achieve operational lifetimes of up to 6,000 hours, corresponding to approximately 2,000 adsorption-desorption cycles. After regeneration, they can be returned to the soaking stage to extract additional rare earth elements.
Fino a 6.000 ore, quindi corrispondenti a circa 2.000 cicli di assorbimento e desorbimento, e quindi verranno desorbite e rigenerate e rimesse di nuovo nella sezione di bagnamento dove estrarranno nuove terre rare.
With that, I think I'm finished. Thank you very much, and I'll pass the floor to Alessandro. Thank you, Mauro. It was a pleasure listening to your presentation. Now, I'd like to ask Andrea to join us again while I remove the slides and make room for questions.
Rimuovo le slide e diamo spazio così alle domande.
As I scroll through the live chat, I'd also like to invite anyone who still has questions to post them now.
Per invitare chi avesse altre domande da porre a scriverle in chat.
We have a few minutes available for discussion.
Alla risposta alle domande.
The first question comes from Takele in Ethiopia and is addressed to Andrea. Takele is asking whether calcium carbonate can be considered a potential resource in geothermal brines, even though carbonates are often directly exposed at the surface.
Se ne trovi anche in superficie, i carbonati siano esposti direttamente.
Benissimo, rispondo in italiano, ho visto che la domanda è
certo,
arrivata
sì, perché poi ci sarà una versione inglese che verrà pubblicata con voiceover la settimana prossima, come per ogni lezione precedente.
Yes, the question is absolutely reasonable. Calcium is often very abundant in highly saline geothermal brines. However, rather than representing a resource, calcium is more commonly a problem, as it tends to cause scaling and operational issues within geothermal systems. First of all, because it does not have a high market value, unlike lithium, boron, and other elements, or even colloidal silica, which is nevertheless a highly sought-after material. So it becomes a problem because as fluids move from depth toward the surface, changes in the thermodynamic conditions cause calcium to precipitate. This leads to incrustations and scaling, blockage of wells and pipelines, and ultimately an increase in operating costs. Operating costs to do what? Essentially, a large part of the engineering effort is devoted to preventing the precipitation of calcium carbonate or calcium sulfate. So let's say it is not a material, it is not a metal that the geothermal industry looks to valorize at the production level. It is more of a problem that needs to be managed and solved.
Creare un valore aggiunto a livello produttivo. È più che altro un problema da risolvere.
Great, thank you very much. This actually ties in well with a question asked by Brenda. Her question concerns the costs of exploitation, specifically the costs of geothermal energy production in general, and whether mineral extraction can somehow influence the cost-benefit balance and make the overall system economically sustainable and advantageous.
Rendere economicamente sostenibile e vantaggioso il tutto.
The way I presented it in the slides was, of course, intentionally optimistic. Being able to develop a geothermal system that produces electricity provides
e
district
poter
heat and at
sviluppare
the
un
same
sistema
time yields
geotermico
critical
che
metals such as
produce
lithium
energia
boron
elettrica, si
and
fa
others
teleriscaldamento
would
e
be an
abbiamo
ideal
anche una
situation,
produzione di
even for a
metalli
country like
critici
Italy,
come il litio,
which has
l'oro.
essentially abandoned the mining sector
È
for the
una
past 30
sarebbe una
years.
condizione
It would
ideale,
be
no?
the
Anche per far
simplest and most
ripartire
socially
in un
acceptable
paese
way
come
to
l'Italia
relaunch
che
a
ormai da
mining
20
sector.
anni che ha abbandonato il
However,
settore
it is not that
minerario,
easy. The
sarebbe il modo
question is well posed,
più
and it
semplice,
ultimately
più
comes down to
accettabile anche dalle
business planning.
popolazioni per far ripartire un settore
Extractable
minerario.
metals can
Tuttavia non è
theoretically
così
help the
facile, la
production
domanda è ben
process
posta
and the overall industrial
devi
system,
mescolare
but we are really
i
coming back to the
metalli
same discussion we had
estraibili
about calcium.
teoricamente
We
potrebbero
need to
aiutare
understand which metals and materials can
processo
actually be
produttivo, il sistema
extracted
industriale,
and whether they have
tuttavia appunto si
sufficiently
ritorna
high
un po' al
value to
discorso che abbiamo
justify the
fatto sul
effort.
calcio. Bisogna vedere quali metalli, quali
Lithium
materiali
and
si
boron,
possono estrarre
certainly,
se
as
hanno un
well
alto
as
valore. Litio e
cesium,
boro
rubidium,
sicuramente sì,
and colloidal
cesio,
silica,
rubidio,
but
silice
certainly
colloidale,
not
non
calcium
certo
or
calcio e
sodium.
sodio.
In
Nel
the
caso
case
di
of Chisano,
Cesano che abbiamo
we
visto
saw
nelle
in the final
ultime
slides of my
slide della mia
presentation,
parte
there
di
are enormous
presentazione,
quantities of potassium
si è
sulfate.
visto che ci sono
Potassium
enormi
sulfate is
quantità
not a
di solfato
particularly
di
valuable
potassio.
compound,
Il solfato di
but
potassio
because it
non
is
è
present in
un
such large
composto
amounts in the fluid, it would likely
particolarmente,
become an important
diciamo,
byproduct if industrial
pregiato,
activity were
però
ever to
siccome ce n'è
start in Chisano.
tantissimo in quel fluido,
Another key
probabilmente
aspect
diventerà
is
un
concentration.
sottoprodotto
Working with a
importante
fluid
se
that
mai
contains
partirà
200
un'attività
to
industriale a
300
Cesano.
milligrams per liter of lithium
L'altro
is
aspetto
one
sono le
thing.
alte
Working with
concentrazioni,
fluids
cioè
that contain
lavorare con
less
un
than 100
fluido
milligrams per
che
liter
ha
of lithium
200,
raises a different
300
set of
milligrammi al
challenges.
litro di litio non
However, for
possa
example,
lavorare
in
con dei
systems like those we
fluidi
saw in
che hanno
Canada, in
meno di
Alberta,
100
in
milligrammi
areas of
litro,
former
ovviamente
hydrocarbon
pone altri
deposits,
problemi.
lithium
Però, ad
concentrations are
esempio,
generally below
in
100
sistemi come
milligrams per
quelli che
liter.
abbiamo visto in Canada, nell'Alberta, nelle zone degli ex giacimenti a idrocarburi, lì le concentrazioni sono sempre inferiori ai 100 milligrammi litro.
On the other
Tuttavia,
hand,
la
the
chimica
overall
generale del
chemistry of those
fluido
fluids is
è,
often
ad
more
esempio,
favorable than that of
più
fluids like those in
favorevole
Chisano, which are
rispetto
extremely
a
rich in
fluidi come quelli
salts.
di Cesano, che
So,
sono
it is always a
ricchissimi
matter
in
of
sali.
balance
Quindi ecco, è
between
tutto un bilanciamento,
concentrations,
no? Tra
the value of the
concentrazioni,
metals,
valori del
and the flow
metallo,
rates of
le
the
portate
wells.
dei pozzi. Una
It
cosa è
makes a
avere un
big
pozzo che
difference
mi
whether a
porta in
well produces
superficie
10 tons of
10
fluid per
tonnellate
hour
ora
or
di
200
fluido,
tons per
una cosa è
hour.
averne un pozzo che mi porta 200 tonnellate ora.
And
E
clearly,
chiaramente tutto
the
il
entire
dimensionamento
sizing of the surface plant
dell'impresa di
depends on
superficie
these flow rates and
va a
ultimately on
giocare anche su questi
costs. The
concetti delle
systems
portate.
Mauro
E
showed
poi
are, in many
ovviamente i
cases,
costi,
patented,
i,
but they
i sistemi che ha
also
fatto vedere
always need to
Mauro
be adapted to the
chiaramente
specific
in
chemistry
molti
of the
casi
geothermal
sono
fluid in
patenti,
question.
ma in molti casi sono sistemi che vanno adattati al fluido geotermico del nostro sistema geotermico.
Sempre.
E quindi,
No.
no, giusto finisco l'ultima parola.
This
Quindi ecco,
industrial adaptation
questo
involves costs, and all of these
industriale
factors need to be
comporta
carefully
dei costi.
evaluated
E
together.
quindi ecco, tutti
At
questi
the
aspetti
moment,
qui
the
vanno
horizon is
messi in
still somewhat
circolo
distant.
e a quel
The
punto si
Salton
potrà
Sea
dire,
projects are
tuttavia
beginning, and
l'orizzonte in
other
questo
projects will
momento è
follow.
ancora lontano.
Hopefully,
Sta partendo
exploration
Salton
activities
Sea
will also be
e
carried out in
partiranno altri
Italy,
progetti. Si
and
spera
within
che in
5 to
Italia
10
si
years,
faccia
this could
l'esplorazione
lead
che
to an
fra
industrial
5
vision
anni, 10
if the
anni
resources are
porterà
there.
ad una visione
So,
industriale forse, se
making
la
a
risorsa c'è.
definitive judgment
Ecco,
now
quindi
would
giudicare
probably
ora
be
è un
premature.
po' forse anche
I would wait a
troppo,
few
un
years
po'
to see
troppo
some
presto.
projects that
Io
are, let's
aspetterei
say,
qualche
at a
anno per
more
vedere
advanced
qualche
stage of
progetto che
maturation.
va, diciamo, in una fase di maturazione più avanzata.
Thank you.
Grazie.
Sì, confermo
Yes,
pienamente.
I fully
Ogni
agree.
sistema
Each
è
system is site specific.
sito
The characterization
specifico,
of the
la
brine composition
caratterizzazione
is
della
absolutely key.
composizione della
All
brine
aspects
fa
must
da
be
padrone,
balanced.
bisogna
First and
bilanciare
foremost,
tutti
the
gli
economic one,
aspetti,
obviously, but
innanzitutto
also
quello
the
economico
environmental
ovviamente,
and
ma poi ci
social
sono anche quello
aspects, as well as
ambientale,
the
quello
issue of waste
sociale,
production, as
i
mentioned
rifiuti che
in
si
other
producono, perché poi
interventions.
abbiamo
There
anche
are
questo
also
aspetto,
particular challenges,
magari non
such
so se
as
è stato già
brines
detto
containing
negli altri
radionuclides,
interventi,
which must be
ma
managed
abbiamo
carefully
anche chicche
because they
strane
tend to
tipo
accumulate in
brine
scaling and
con dentro
deposits.
dei contenuti
These then
di
become a
radionuclidi che
problem when
debbono
they have to be
essere
removed and
in qualche
disposed
maniera
of.
gestiti perché si accumulano nello scaling, nei depositi che quando vanno rimossi diventano un problema. Quindi diciamo
So, in
ogni
short,
sistema
every
fa un po'
system
storia a
is
sé.
different. We
Siamo,
are,
come
as
diceva
Andrea was saying,
Andrea, ancora a
still
un
at a
livello
relatively early
abbastanza
stage in
iniziale
addressing this type of problem,
nell'affrontare questo
with the
tipo di
aim of arriving at solutions that are industrially
per
viable.
avere delle soluzioni che
There is
siano
therefore
poi
still a
industrialmente
lot of work to be
interessanti,
done, and in a
e
positive
quindi
sense,
c'è da
also a
lavorare,
lot
ecco,
of
mettiamo che c'è da
intellectual
lavorare e anche da
challenge and
divertirsi,
interest
nel
in doing
senso
it.
buono del termine.
Sicuramente.
Oh, certainly.
E
And
Mauro,
Mauro,
ho per te una
I
domanda
have a
molto
very specific question
specifica,
for
cioè
you.
perché il litio non
Lorenzo
si
is
estrae
asking
per
why lithium
precipitazione?
is not
E questa la
extracted
pone
by
Lorenzo.
precipitation.
Ok, allora
Okay,
sì, il litio,
so lithium
beh,
is an
intanto il
extremely
litio
soluble
è
element, and in fact, we find it
un metallo
very well
estremamente
dissolved in
solubile, e
brines.
infatti lo
Very
troviamo
few lithium
benissimo
compounds form
solubilizzato a
precipitates,
pochissime
most notably
specie,
lithium fluoride
pochissimi
and in some
composti
cases
per
lithium
cui dà dei
phosphates.
precipitati.
In
In
practice,
particolare
however, precipitation is
dà
not
fluido di
used for
litio
separation because
e anche
adding
solfati
fluoride
dà
or phosphate
dei
to a
sali
brine
insolubili.
would not
In
selectively
realtà non si
precipitate
fa
lithium alone.
una
It
separazione
would
per
also trigger the
precipitazione
precipitation
proprio
of
perché
other
se
species, such as
aggiungessi
silica. For this
fluoruro
reason,
o
it has
fosfato
so far been
all'interno
considered
della
more
brine non
convenient to keep
precipiterebbe
lithium in
solubili,
solution and to use
precipiterebbero
technologies that
con
allow it to be
silice, e quindi
separated
in qualche
while
maniera
remaining in the
si è
dissolved
risultato fino
phase.
ad ora conveniente
As we discussed,
mantenerlo in
lithium can be
soluzione,
absorbed,
utilizzare
separated by
tecnologie
ion
che lo
exchange,
vedono
transported
separabile
through
sempre
membranes,
in
or
forma
handled
di
via
assoluto.
electrochemical
Poi
methods.
appunto, come dicevamo, può essere
Precipitation is generally
assorbito, può
avoided,
essere
also
fatto in
because
solfato
lithium
ionico, può essere fatto
concentrations,
passare la
even
membrana,
in the
ma
best
si
cases,
preferisce
are only a few
non
hundred
farlo precipitare, anche
ppm
perché le
compared to the much
concentrazioni,
higher
quando va bene, sono di
concentrations of
qualche
other
centinaia di
ions present
ppm
in geothermal
rispetto
brines.
diciamo, al mare
This
di
means
ioni
that
che c'è
if I try to
dentro una
precipitate
salamoia a
lithium,
concentrazioni
in
anche molto più
reality, I will
elevate.
find it embedded
Questo
within a
vuol dire
mass
che
of
se lo voglio
precipitates
far
made up
precipitare, in
of
realtà
many other
lo troverò
substances. In
a sua
other words,
volta
lithium would end up
come
mixed
precipitato
into a
dentro un
sea of
mare di
other
precipitate di
precipitates,
altre cose, quindi non
making
è un
separation
sistema che al
extremely
momento viene
inefficient.
reputato
For
come
this reason,
interessante
precipitation is
per la sua
not currently
separazione.
considered an attractive or practical method for
E
lithium
senti Mauro, un'altra
separation.
domanda
And
per te
listen,
invece
Mauro, there's
riguarda
another
il fatto
question
che
for you. It
l'estrazione di minerali
concerns
sia
whether mineral
applicabile
extraction
anche a
can also
fluidi da
be
pozione
applied to
in
pore
gas.
fluids and
Beh sì,
gas-related fluids.
poi
Oh, yes,
l'ha
Andrea
già
already mentioned this,
accennato
and the answer is certainly yes.
Dini.
If
Sicuramente
formation
sì,
waters from oil and
sono
gas wells
se
that are
nelle acque di
intentionally brought to the
formazione
surface contain
del pozzo oil and
concentrations
gas,
of interesting
che
or critical
volente o nolente
materials,
viene portato a
lithium for
giorno,
example,
si
then why not
trovano delle
consider
concentrazioni
extracting them?
di
One could
materiali
envisage an ad hoc
critici
separation
interessanti, in
process,
particolare
and
il
in
litio ad
doing
esempio,
so, also
perché no?
valorize
Potremmo
gas
pensare
wells
di
that
fare
may
una
be
separazione
exhausted
ad
and no
hoc
longer
e
productive in
valorizzare
terms of
anche dei
hydrocarbons.
pozzi oil and gas che
The
magari
associated
peraltro
water,
possono essere
production
esauriti,
water,
quindi non hanno
is
più la
in any
funzione
case a waste
di
stream that
estrazione di
must be
idrocarburo,
managed
ma siccome
once it reaches the
l'acqua che
surface.
di fatto è un
Under the right
rifiuto
conditions,
e deve
it
essere
too
anche
can be
gestita nel
valorized,
momento in cui viene
provided that the
a
economics make
giorno
sense.
come acqua di
In
produzione,
short, we are
anche lei
dealing with
potrebbe
a
essere
waste that can
valorizzata
potentially
se
become
ci
a
sono le
resource.
condizioni, come dicevo, economiche per farlo, e comunque diciamo siamo in presenza di un rifiuto che può diventare una risorsa, ecco.
Great,
Benissimo,
thank you.
grazie.
And just to
Questa
clarify, that
domanda
question was
non l'avevo
asked
detto,
by
ma era
Marika.
stata posta
Now, I'd like to
da
ask you,
Marica
first Mauro and then
e
Andrea,
adesso
for a more general
ti
comment.
porrei,
I'll try to
magari
group the final
chiedendo
questions
prima a
together.
Mauro e poi a Andrea di fare un commento generale, vi porrei le ultime domande provando ad accorparle, per cui le domande sono le seguenti.
Paolo
Allora, Paolo
asks
chiede,
whether mineral
l'estrazione dei
extraction
minerali
can
può
take
avvenire
place
subito,
immediately
anche prima del
before the
separatore
separator
dello
and the heat
scambiatore del
exchanger of
power
the power plant.
plant, però
But let
aspettate
me
perché
add
ve ne
two more
pongo altre
questions
due
that,
che
in
per
my
come le
view, allow for a
intuisco
collective answer
mi
and help save
consentiranno
time.
di dare una
Frank
risposta corale e
asks whether
risparmiatrice.
extracting
L'altra
materials after
invece
energy
la pongo a
production
Frank, che
could
chiede il
interfere
fatto
with
che
or negatively
i
affect
minerali
the
siano
proper
estratti
operation of
dopo
the
la
power plant
produzione
itself.
di energia. È
And
un
finally,
problema
Gennaro
per
asks
la
whether it is possible to
fonooperatività degli
activate mineral
impianti di
recovery
produzione dell'energia
downstream of a
stessa. E la
geothermal or
terza
electricity
domanda
production plant,
invece
and
che viene
therefore also
posta da
apply it to
Gennaro è se
existing
sia possibile
installations.
attivare il recupero dei minerali in un secondo momento rispetto all'impianto di produzione geotermica o elettrica, applicandolo quindi anche ad installazioni già esistenti. Allora,
So,
spero
I
che
hope that grouping the
aver
topics together like
accorpato
this doesn't
così gli
create too much
argomenti, non
confusion,
crei
but I would
eccessiva
ask you now
confusione,
to
ma
give a
ti
general
chiederei
comment
di
in
fare un
response to these
commento
questions.
generale in risposta a queste domande.
non so,
Mauro, you
inizi
can
te
start.
magari.
Comincio
Prego.
io,
Okay,
va bene. Allora,
I'll start.
intanto
First of
la
all, the
prima
first
era
question
il fatto di
concerns the
poter
possibility of
mettere
installing a mineral
l'impianto di
extraction
estrazione
plant
minerale
upstream of the geothermal power plant.
Esatto.
In
dell'impianto
principle,
geotermico.
it is possible,
Diciamo
but
che in
in
linea di
practice, it
principio
is not
è
advisable.
possibile,
This is
diciamo
because if
invece che
our
non
goal
è
is to
così
extract energy, we want the brine to
consigliabile
retain the
perché
maximum
se poi
possible
la
enthalpy
necessità di
compared to what
estrarre
it has in the reservoir.
energia, noi vogliamo una brine che abbia il massimo contenuto entalpico rispetto a quello che abbiamo in giacimento. Quindi mettere
Introducing
in
a
mezzo
processing section in the
una
middle of
sezione
the
di impianto
system
che
would
sicuramente
inevitably
perturberà
cause disturbances, heat exchanges,
scambi
and
termici
losses.
e
As a
perdite,
result,
quindi
the energy delivered to the production
l'energia
stage
che
would
poi viene
no longer be
portata
optimal.
allo
In
stadio
fact,
di
it would be
produzione
less efficient.
non è in linea
That
di
said,
principio
I
molto,
always like to
molto,
remain open to possibilities.
molto
Never say never.
efficiente, anzi.
Perhaps one day a technology
Comunque io
will
sono sempre
emerge,
possibilista,
and in
diciamo,
fact, we are
mai
already
dire
starting
mai,
to see
magari
systems
salterà fuori un
that
giorno
attempt
una
to perform
tecnologia o
separations at
qualcosa
very
dove
high
dire che
temperatures.
si comincia a
When
intravedere
we talk about
di
very high
sistemi
temperatures, we
che
mean
provano
systems
a
that
fare
can
delle
withstand
separazioni
several hundred
ad
degrees.
altissime
In such
temperature.
cases,
Quando
some
parlo di altissime
separation
temperature
processes
parliamo di sistemi che
could
resistono
potentially be
anche
integrated
a
into
diverse
what is now
centinaia di gradi
considered the
e in questo
classic
caso
geothermal
ecco che
system.
alcune separazioni potrebbero essere anche fatte di tutto il sistema geotermico classico.
The other
Le
questions instead concern whether
altre
performing mineral extraction
L'altra chiedeva
downstream
invece
creates
se
problems for
si
energy
può
or
fare,
thermal
allora,
production, and whether
una
doing so
differente
makes it
chiedeva se
possible to
il
apply
fatto
these
che si faccia
processes
a
to
valle
existing
non
plants.
crea dei problemi agli impianti per la produzione invece di energia o per la produzione termica. E
qui
l'ultima
bisogna
chiedeva invece se il fatto di farla dopo non consenta di farla anche in impianti già esistenti.
Regarding the
l'ultima
latter, the
sì,
answer is
sicuramente
definitely
sì.
yes.
Come
As I
dicevo, è una
mentioned
sorta di
earlier, this would
retrofit
essentially be a retrofit of geothermal power plants,
centrali
where a
geotermiche
mineral extraction
a cui
system is added
aggiungiamo
downstream of energy
il sistema
production.
di estrazione minerale. Il fatto che possa influenzare la volontà di estrarre minerale alla precedente produzione di energia. Allora, qui
However,
bisogna
we
stare
must be
attenti
careful.
che la produzione di
Energy
energia
production does not tolerate all the problems
non
associated
vuole
with
tutte quelle
deposits, scaling,
problematiche
and corrosion,
legate
issues that are
ai
inherently
depositi,
linked to the
scaling,
chemical species
problemi di
dissolved in the brine.
corrosione, che sono tutte,
On the other
diciamo,
hand, those
connaturate
very same species are what we would
alle
like to
specie chimiche che
valorize
sono
through
disciolte
mineral
nella
extraction.
brine.
Therefore, we need to
Dall'altra
find
parte
a
noi invece
system-level
vorremmo
solution that allows
utilizzarne alcune
us
di
to
queste per
avoid
poterle
damaging heat
valorizzare. E lì
exchangers,
bisogna trovare una
separators,
soluzione
turbines,
intelligentica che permetta
everything that is part of the
non arrivare
geothermal energy production
a
system,
danneggiare
while at the same time keeping
gli
the target mineral
scambiatori,
in
i
a condition that
separatori,
allows it to be
le
extracted
turbine,
in
tutto quello
subsequent
che è
stages.
l'impianto geotermico per la produzione di energia, e quindi magari bisognerà fare anche delle azioni in questo senso, ma mantenere il target, il minerale target che vogliamo in una condizione estraibile per le fasi successive. Quindi
In
realtà,
reality,
ecco,
the
gli
schemes
schemi
shown
erano
so far are
semplificati,
simplified.
bisogna anche lì
What is needed is
lavorare,
step-by-step
diciamo,
development,
passo passo
ensuring
per
that
far sì
each
che
section of the
ogni
plant
sezione di
works properly
impianto
and at a high standard of
funzioni bene,
quality,
funzioni
so that we avoid the
con
classic
un
chicken and
ottimo
egg problem.
che permette di non di avere, insomma, come si dice, l'uovo e la gallina, ecco, questo voglio banalizzare un
Now I
po'
want to trivialize this a bit with a metaphor.
questa metafora.
Thank you,
Ti
Mauro.
ringrazio, Mauro,
I will
e
now give
darei
Andrea
ad
the floor for
Andrea
a
la
comment on
parola
these
per
final
un
topics.
commento su questi ultimi argomenti.
Yes, okay. Mauro has already
Vabbè,
explained
Mauro
the
ha
situation
già
very clearly.
ampiamente
One aspect that
spiegato
perhaps
il
should be
punto della
recalled, and which
situazione.
is having an impact in
Un
virtually
aspetto che
all
forse va
countries where these types
ricordato
of
che
exploration and industrial activities
sta
are being
impattando
developed
un
is
po' con tutte le
legislation.
nazioni dove si fanno questi tipi di esplorazioni e di attività industriali, è la normativa. Cioè,
Up to
e fino
now,
ad
we
oggi
have been
siamo stati
accustomed to
abituati, no,
developing mineral
a sviluppare
exploration in geothermal
esplorazione
fluids and
mineraria
building
per
plants
studi
that produce energy
geotermici
under
che
regulatory
hanno preso
frameworks
impianti, producono
specifically designed for
energia
energy
con
production.
una normativa che appunto
Today, however,
regolava la
we are moving
produzione di
toward a
energia.
much more complex
Oggi si va
system in which, in
un
addition to
sistema molto
energy,
più
metals
complesso
can be
dove
produced.
oltre
This
all'energia si
creates a
potrà
problem
produrre anche
because many
metalli.
regulatory
E a questo
frameworks,
punto
starting with the
viene fuori il
Italian one,
problema perché
are
molte
not yet
normative, a partire
adequately
da quella
suited to
italiana,
this
non sono
new
ancora
industrial
ben
scenario.
adeguate a questa
This leads to a number of
utilizzazione
issues that I won't
industriale.
go into detail,
E questo
especially since I am
comporta
certainly not the most
tanti
qualified
problemi
person
che
to
io non vi
address them.
sto a spiegare in
But the
dettaglio,
key
anche perché
point to
non
keep
sono
in mind is
sicuramente la
this.
persona
Does our
più
activity primarily
informata
produce energy,
sull'argomento.
or does
Però
it
ecco,
primarily produce
il
metals?
punto da ricordare
Where
è
does the
questo,
value
cioè
generated
la
come
nostra
from
attività
energy or
produce
from the
più
metals?
energia
Or perhaps
o
from
più
both, but in
metallo,
different
cioè il valore
proportions?
prodotto è
Depending
quello
on these
dell'energia o quello
proportions,
del
the
metallo,
type of
oppure quello del
concession,
metallo
the
e
taxation
è meno quello
regimen, and
dell'energia. Ecco,
everything that
a
affects
seconda
industrial
delle
activity
proporzioni,
changes accordingly.
il tipo di concessione, il tipo di tassazione, tutto quello che va a impattare poi sull'attività
These
industriale
aspects are
cambia,
often not
spesso non è
adequately
normato in
regulated,
maniera
and this
adeguata
represents a
e
major
quindi ecco è
challenge
una
for the
grande
coming
sfida
years,
dei
not
prossimi
only
anni,
from a
non solo
scientific and
scientifica,
industrial
non solo
perspective,
industriale, ma
but also
anche
from a legal
giuridica
and
e
regulatory
normativa.
one. A very
Molto
interesting and
interessante e
complementary perspective. Thank you very
complementare. Grazie
much.
mille. Io con
I sincerely
questo
thank
vi
you for this
ringrazio
lecture and for
davvero
answering the questions so
per
thoroughly.
aver tenuto questa lezione e aver risposto in modo così
I thank
esauriente alle
everyone who
domande.
contributed to
Ringrazio
this
chi ha
final
animato
discussion
con le
with their
proprie
questions,
domande
also for the
questa
benefit of those
discussione
who will follow
finale
this
a
session on
beneficio di
demand.
chi poi seguirà on demand.
I would like to remind
Ricordo
those
a
who are
chi non
not yet
fosse già
registered with the
iscritto al
MOOC
MOOC
that
che
this webinar is
questo
part of a series
webinar
of
è
8
parte
video
di un
lessons
percorso
covering the
che si
value chain,
compone di
all
8
available
video
on the
lezioni che percorrono
Mooc.Uniurb
la catena
platform.
del valore
You can
e
register
che
for free using any
è
social media account
complessivamente
or a valid
fruibile
email
sulla
address. I
piattaforma
encourage you to do so, as the platform not only
mooc.uniurb.it,
provides
alla quale ci
on-demand
si può
recordings,
sempre
but also copies of the
iscrivere
slides,
gratuitamente
as
con
well
qualunque
as
account
self-assessment
social
and
o qualunque
consolidation tests
indirizzo
for each
email
lesson.
valido. Vi invito a farlo perché all'interno della piattaforma troverete anche, oltre che la registrazione per la fruizione on demand, troverete anche la copia delle slide e i test di autovalutazione e consolidamento legati ad ogni lezione.
A week
Una
after each
settimana
lesson, you will
dopo
also find the
l'applicazione di ogni
English version
lezione
with
troverete
voiceover.
anche la
At the
versione
end of the 8
inglese con
lessons, you will be able
voiceover
to download a
e
certificate
al
of
termine delle
completion
8
issued by
lezioni
the
potrete
University of Urbino and
scaricare
Saipem.
l'attestato di completamento rilasciato appunto dall'Università di Urbino e da Saipem.
With
Con
that,
questo
once
di
again,
nuovo
thank you and
grazie e
congratulations to
complimenti a
Mauro and
Mauro e
Andrea.
ad Andrea.
Thank you all.
Grazie.
Goodbye and best regards.
Arrivederci.
Saluti.